All right. So what we've been talking about the past few weeks is the basic algebra, specifically of polynomials, but also of rational functions, square root functions, exponents, stuff like that. And we're going to apply more or less all of those concepts into inequalities. So we've been talking about equations, which are true equalities. Now I'm going to talk about inequalities, because they solve similar to equations, but they're not the same as equations, and so we need to highlight those differences. For something like what is known as a linear inequality, an example would be maybe 4x plus 11 is less than or equal to 19. For an example like that, I can just treat that like an equal sign, solve it, and then recover my sign. Who's seen an example like this before and solved something like this before? Most people. So all I do here is I subtract the 11 on both sides. 4x is less than or equal to 19 minus 11 is 8. Divide by 4 on both sides, so x is less than or equal to 2. Remember when we've talked about intervals and such before, we've written them in interval notation and also on the number line. Whenever you're doing inequalities like this, I always recommend draw it on the number line first and then do your interval notation, because it'll make it a lot easier. So on the number line here, this point I'm worried about is 2. Less than or equal to, is that going to be an open or closed circle?
Closed.
Closed, because I've got that equal to there. And less than just means I'm going down this way, going to the negative number, something small. So that's your number line drawing of it. Pretty straightforward. It goes down to the numbers that are less than 2, so like 1, 0, -1, all those are over here. And then in interval notation, I'm going from minus infinity, I never include infinities, they always have round brackets, up to 2, and then because it's closed, I get a square bracket. Which is what we saw beforehand when we were drawing out intervals on the number line and then translating that into set notation or interval notation right there. Infinities are always round brackets, open circles are round brackets, closed circles are square brackets or hard brackets. This is good and all, and this works out for anything. So we'll list out maybe some rules of these, or what inequalities follow. So they have addition. That means if A is less than B, A plus C is less than B plus C. So adding stuff to both sides doesn't change the sign in the middle. Same thing with subtraction. 5A less than B, A minus C is less than B minus C. So subtraction does not change the sign either. Multiplication is not necessarily so simple though. There's 2 cases for multiplication that we have to consider. The first one is if I multiply by a positive number, my sign doesn't change. So for example, if x is less than 3, 3x is less than 9. That's true. However, if I multiply by a negative number, I flip the sign. So in this instance, negative 3x is greater than negative 9. multiplying by negative 3 on both sides. Basically, the idea is I'm flipping the entire number line around and going down the other way. So just an important note, highlight in your book wherever you need to. Negatives flip inequalities. That's an important thing to remember there. We can also have what are called compound inequalities. So this is a simple or a singular inequality, but we have compound inequalities, which are something like A less than X less than B. So it's just saying that whatever value we're interested in is sandwiched in the middle of two other values. So for instance, I can have 3 less than 2x plus 1 is less than 9. And now the question would be, write the solutions of x in interval notation, because there's several x's that solve this. So I just treat it like an equation, but now what I do to any part, I have to do to all 3 parts. So if I subtract 1 in the middle, I have to subtract 1 from the left and from the right. 3 minus 1 is 2, less than 2x, less than 8. And then now I want to divide by 2 in the middle, so I have to do it on the left and the right as well. And I have 1 less than x less than 4. When we have compound inequalities, we always write it smallest to largest, and the arrows always point towards the left, because that satisfies smallest to largest. So then putting this on the number line, I go to the 2 points I'm interested in, which are 1 and 4. Since I have strictly less thans, am I going to have open or closed circles? Open, because I don't have equality. And then I shade in everything between them. So x is everything that exists between these 2 circles. Then in interval notation, open bracket, 1 to 4. Be careful to not think this is a coordinate point. I know we've done coordinate geometry in the past. This is how we notate points, but this is instead just an open interval. And more specifically, x is somewhere in that open interval. So any number that I pick out of here satisfies this. 2, 2.5, 3, pi, all of those satisfy this inequality here. But 1 and 4 don't, because then I'd have strict equality there, and I wasn't asked for that. Now an example to highlight this negative phenomenon. What if I have 4 less than or equal to 1 minus 3x less than or equal to 13. So I want to get rid of this 1 here. I'm going to subtract 1 from all 3 pieces. So I get 3 less than or equal to negative 3x less than or equal to 12. Now with single inequalities, it's pretty easy. I just flip everything over. Compound inequalities, I have to flip the entire thing over when I divide by a negative. So if I divide by -3 in every place, I have to mirror the entire thing. So I'm gonna like visually mirror it so that you kind of get what I am saying. So I've got -3/3 is -1. Then mirror this sign, so I get greater than or equal to. That just becomes x. And then greater than or equal to, I get -4. That's not entirely true though. I don't want to mirror everything. Because -4 is not greater than -1. What do I mean to say instead? All of the signs do flip. This is true. So I get -1, flip that sign, x, flip that sign, -4. So flipping the signs is true, but remember that we want to write it smallest to largest. So I want to put this over here, and the sign with it, then x, the sign with it, and -1. So I first flip the signs, and then I can mirror everything around. That's better. So if I was mirroring this second one right here, I get -1 greater than or equal to x greater than or equal to -4. So flip all of your signs and then mirror it around, and you'll get the correct answer. That's again because we're basically taking the entire number line and flipping it around, so we have to preserve the direction of our inequalities there. Any questions about this?
Can you do it?
Yes, of course.
Addition, subtraction, what is this?
Huh?
Addition, subtraction, right?
This is technically all of them. I had subtraction and I had multiplication or division. So say I had 2 less than or equal to 3 minus 4x less than or equal to 5. How about that? The numbers aren't going to be as clean, but the idea will hold. First thing I want to do, subtract this 3 everywhere, so there's my subtraction. 2 minus 3 is -1. I get -4x, and I get 2. Then I divide by -4. When I divide by -4, I flip all of my signs. So I get 1/4 greater than or equal to x greater than or equal to -1/2. And then I mirror the entire thing around. -1/2 now less than or equal to x less than or equal to 1/4. The whole mirroring thing should logically make a little sense, because if 1/4 is greater than or equal to -1/2, which is true, flipping it around, -1/2 should be less than or equal to 1/4. Compound inequalities should always be true if I remove the middle part. Here, removing the middle, I get 2 less than or equal to 5, which is true. Removing the middle part, I get 1/4 greater than or equal to -1/2, that's true. Moving the middle part, I get -1/2 less than or equal to 1/4, which is true. So it should be true without middle And then again, we can graph this. I didn't graph this one either. That's -4, -1, closed circles, and everything in between. And same thing here. -1 half on my number line to 1/4. Closed circles and everything between. And that tells me my interval is square bracket, -1/2, 1/4 square bracket. What's important to notice about the mirroring is if one of these wasn't an equality, for instance, if I dropped the equal sign here, then when I mirror it, the sign in between x and 1/4 cannot be an equality anymore. So that's why the mirroring thing is important, because I'm not just turning these signs around, they have to maintain their relative position between, for here, x and 1/4, for here, x and 1/2, -1/2. So then this would be an open circle here. So that's why I say it as flip, then mirror. Flip your signs and then mirror the entire thing around so that it then goes from smallest to largest. Because multiplying by negative will switch what's smallest and largest. Any questions about this? Does everyone have these rules written down? So this is pretty straightforward when we have linear stuff, but what if we have a nonlinear equation and we're trying to do that? For instance, what if we had x squared minus 5x less than or equal to -6? What is the methodology for doing this? And this is where drawing out your number line is going to become very, very useful. I want to always rewrite anything like this, if it's nonlinear, as everything on one side and then a 0 on the other side. So I'm just going to add 6 to both sides. I can still do that. You get x squared minus 5x plus 6 is less than or equal to 0. And then I want to factor this side. So step 1, move all to one side. Step 2, factor, we'll see slash simplify side. So this factors into, the factors of 6 that add to -5 would be -2 and -3. So x minus 2 times x minus 3 less than or equal to 0. And now I want to draw out my number line. So number line, place where side equals 0. So I want to label on here the points that are going to make this equal to 0. So it's going to be +2 and +3. I'm going to put above them that they're 0. I then want to look at the values between these ranges. So I want to look at something that's less than 2, plug it in here and see what I get. Something that's between 2 and 3, plug it in and see what I get. And then something that's greater than 3, and plug it in and see what I get. So something that's less than 2, for instance, maybe 0, that's an easy one. If I plug in x equals 0, I get 0 minus 2 times 0 minus 3. That's a negative times a negative. And what's a negative times a negative?
Positive.
Positive. So this is positive. I'm going to put a plus there. Something between 2 and 3, I'll pick maybe 2.5 or 3 halves. Put 2.5. Plugging in x equals 2.5, I get 2.5 minus 2 times 2.5 minus 3. 2.5 minus 2 is 0.5. 2.5 minus 3 is negative 0.5. That's a positive times a negative. What's a positive times a negative? Negative. So there's a minus there. And then something greater than 3, I'll pick 4, just because I can. It doesn't matter what I pick as long as it's greater than 3. So for x equals 4, I get 4 minus 2 times 4 minus 3. That's 2 times 1, which is a positive times a positive, which is a positive. So now I've drawn out what this entire function looks like versus if it's positive, negative, or 0. And now I can answer the question, where is this less than or equal to 0? That's what the entire question was wanting me to find. So what regions is this less than or equal to 0? Well, I've got it where it's 0 here, so I'm going to include this. Got it 0 here, so I'm going to include this. And then it's negative in between those, which is what I want. And that's my solution. That's the interval that satisfies this nonlinear inequality. So place where side equals 0. Pick points between zeros to find plus or minus. Label number line. So we moved everything to one side first. We factored or simplified this side, so I factored it into these terms, which allowed me to place on the number line where the function is 0. And then I picked points between those zeros to figure out what the number line was doing otherwise, if it was positive or negative in those regions. And then I labeled my number line with the positive region, positive region. Now that my number line is fully set up, I just write out my interval. Is this going to be a square or round bracket? Square, because I've got a closed circle. 2. And is this going to be a square or round bracket? Square. And that's my interval. X is between 2 and 3. It can also be equal to 2 or 3, because that would satisfy the equality of this less than or equal sign. These are complicated. We will do some more examples just so that you'll see it a little more. Any questions about this though? Again, this is a kind of weird example. Or not a weird example, this is just a weird idea in general. So we'll do more examples. I'll let y'all write down the rest of this as y'all need to. Are there any questions at all about, yes?
Why are 2 and 3
Because they're equal, the function's equal to 0 here, and it asks for where it's less than or equal to 0. And so that's why we put those points, because they are equal to 0 there. Good question. Any other questions? Yes?
Where did you get the 2.5 for? Was that just random numbers?
I just picked random numbers that were on the opposite sides of these values. 2.5 was the first number I thought of between 2 and 3. I picked 0 here because it's pretty easy to plug 0 into this. And I picked 4 because it was the first number I thought of after 3. When you go on to calculus, you'll see this a lot, even in business calculus. You'll talk about where a function is increasing or decreasing. You'll do very similar things, and you'll just pick random values to test. So yeah, those numbers are just picked from random. But it had to be less than 2, had to be between 2 and 3, had to be greater than 3. Any other questions? We'll do another example of a nonlinear inequality that we're solving to kind of iron it out a little bit more. So for instance, I have x cubed minus x squared minus 6x is greater than 0. Well, I already have step 1 done for me, so that's pretty nice. I want to factor or simplify this side. What do all 3 of these terms have in common? X. So I'm going to factor out an x. I get x squared minus x minus 6 greater than 0. And then I can factor this down. So I want the factors of -6 that add to -1. 1, 2, 3, 6, -6, -3, -2. Which pair of these adds to -1? 2 and -3 plus 2 minus 3 greater than 0. Now step number 3 says on a number line, place where this side equals 0. So I'll do that here. So this is going to be 0 at x equals 0. If I plug in 0, this is 0. At x equals -2. And at x equals +3. It's 0 at these places. And now I want to go between these points and pick out values to test whether it's positive or negative in that region. What's a number that's less than -2? -3 works. What's a number between -2 and 0? -1 works. What's a number between 0 and 3? 2? 2 works. And then what's a number greater than 3? 4. Perfect. So now we'll just plug those values into this and see what we get. For x equals -3, I get -3 times -3 plus 2 times -3, oh, not negative. Yeah, -3 minus 3. Okay, we're good. That's a negative. -3 plus 2 is -1. -3 minus 3 is also negative. What's a negative times a negative times a negative? Negative. You get a positive and then a negative. This implies to the plus minus, which is minus. So I'm negative in this region. I'll put a minus sign there. We'll then do -1. So I get -1 times -1 plus 2 times -1 minus 3. That's a negative. I'll just put minus sign. -1 plus 2 is +1. -1 minus 3 is -4. Negative with a positive is negative. Keep doing -1. And then a negative times a negative is positive. So I get a positive in that region. Now I'm going to plug in 2. I get 2, 2 plus 2, 2 minus 3. 2 is positive. 2 plus 2 is 4, which is positive. 2 minus 3 is negative 1, which is negative. Positive with positive is positive. Positive with a negative is negative. Sorry if I was blocking the board for this half of the room over here. So just plugging in 2 into that equation over there, I get that the value there is going to be negative. And lastly, we want to plug in x equals 3. I didn't leave myself much room, so I'll do it over here. I get 3 times 3 plus 2 times, oh, I can't pick 3, I need to pick 4, my bad. So I get 4 times 4 plus 2 times 4 minus 3. Positive, 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 because that's plus 1, so I get a positive. So it's like the last problem we did, it's just got more regions. And now I'm asking the question, where is this greater than 0? Well, it's this region here is positive. This region here off to infinity is positive. What about these points here? Do I include them or not?
No,
No. Why?
it's not inclusive of 0, it's less than.
Yeah, it's not inclusive of 0, it's strictly greater than. So this is going to be open, I'll do open circles here. Open from negative 2 to 0, union 3 off to infinity. And that's where the solutions lie for this equation here. When we go into graphing equations and everything like that, graphing is another very useful tool for doing this, because a equation like this has zeros at negative 2, 0, and positive 3. Something like this. If I graph this, I can very easily tell where things are negative. Oh, I also have, or tell where things are positive. So this area is positive, which is between negative 2 and 0, and this one is positive where it's 3 off to infinity. So just from graphing it, I can see it a lot easier, but we don't really know how to graph things yet. But when we get there, it'll be a lot easier. I'll just look that up there. Any questions about this?
When you were making the number line, you put -2 and +3, but our original equation was +2 and -3. Why did that change?
Because we want where this equals 0. X plus 2 equals 0 means x equals -2.
Oh, okay.
We mapped out where the zeros are, so it's always the opposite of what's in here. This one is technically x minus 0, which is 0, so it's fine. But I get minus of that, because I set it equal to 0. Any other questions?
So this is what all this is on?
Yep. Whatever it is
Do
here.
you need to do that? Like,
Huh?
you have to do all of that at the bottom just to do that, or you can just automatically put it the opposite side?
Oh no, all this on the bottom was for, oh, are you meaning will it always alternate sign like this? Are you asking about this? The signs here have nothing to do with what we did here.
Okay.
What we did here was finding if it's positive or negative in between the values. So finding, basically, just with numbers graphing it out and then seeing if it's above or below the x-axis by just picking random points. Because if any point between these is above the x-axis, every point between them is above the x-axis. When you go on to do calculus, you'll see a lot more stuff like that. Any other questions?
Are these questions always going to have 0 as what we're trying to, not find, but are you reading me?
Like this side will always be 0?
Yeah,
We'll always rewrite it so that this side is 0.
okay.
Every example you do, you rewrite one of the sides to be 0. The other will always equal 0 there. Great question. We will see why exactly that is with the next example. Or not the next example, but the example after that. Any other questions? Alright, am I good to erase the board? So we're just going to get more and more complicated with these examples as we go along. But it'll give you basically all of the different cases that you'll encounter when doing poems like this. Okay, yeah, that's the one we just did. Yeah, that's fine. So if we have, for instance, 4x over 2x plus 3 is greater than 2, and we're trying to find all the solutions for x there. I'm going to move this over here, so I'm going to subtract 2 from both sides. I get 4x over 2x plus 3 minus 2 is greater than 0. Now to simplify this side, which is step 2, I have to have these over the common denominator. So I have to basically do cross multiplication of fractions here. So that's going to be 4x over 2x plus 3 minus 2 times 2x plus 3 over 2x plus 3. Again, to get them over the common denominator, I just multiply this side by the denominator on top and bottom of the other side. I technically did the same thing over here, but since this denominator is 1, I didn't actually write anything out. And this is still greater than 0. And then I want to combine everything since they're over a common denominator. So 4x minus 2 times 2x plus 3 over 2x plus 3 is greater than 0. And then multiplying that out, I get 4x minus 4x minus 6 over 2x plus 3 is greater than 0. And then lastly, these cancel, so I get negative 6 over 2x plus 3 is greater than 0. Or if I want to make this positive, positive sign and switch. Actually, I'll write that as a whole different step. So greater than 6 over 2x plus 3 is less than 0. For this to be less than 0, the top is positive, so what does the bottom have to be? If this has to be negative as a whole.
Negative.
Yes. Positive divided by negative is negative. So I want where 2x plus 3 is less than 0. I just add 3 to both, or subtract 3 from both sides. 2x is less than negative 3. Divide by 2, I get x less than negative 3 halves. So this is a little different from what we did last time because we were dealing with compound inequalities. Now we're back to single inequalities, but they're a little trickier. This then also requires you to know that to make something negative, if the numerator is positive, the denominator has to be negative. I'll write those out just so you have them. Plus over plus equals minus over minus equals plus. And plus over minus equals minus over plus equals minus. Those are the four possible cases we have. So if instead I asked where this is greater than 0, I'd be asking where this bottom part is positive.
You said they have a possible what?
These are the four possible cases. With a fraction, I can either have plus on plus, plus on minus, minus on plus, minus on minus. Corey, you seem unhappy with this.
What are we talking about?
Who else is completely lost right now? Oh wow. Where did we get lost?
Yes. That is a great.
Where did the 6 go?
Right.
It doesn't matter. It doesn't matter where the 6 went. All that matters is that this has to be negative. The only case where this is negative, 6 is always positive. The bottom just has to be negative. I do not care about the numerator.
Right.
It doesn't have any variable in it. So this could have been a 5, this could have been 12. The reason being is that if I divided both sides by 6, this would be a 1, and I still wouldn't care about it. This would still be 0, so it doesn't change anything. So it doesn't matter what's up here as long as it's just a number. When we do our next example, we'll see the case where that isn't just a number and we have to take care of that. Thank you for that question. Any other questions as to where we got lost?
Can you explain the canceling out of the 4x minus 4x?
4x minus 4x is 0. Oh, so that's, yeah, so that's a negative at 6. And then because this is negative, to make it positive, I just flip the sign.
Wait, so it makes sense. I was just getting confused. I just could not see it.
No, that's okay. It's very easy to overthink this. The other day, my sister-in-law texted me and she goes, -3 minus 0 is positive 3, right? I said, no, it's minus 0. It's still -3. And she got mad at me. Yes.
Where did the 6 go on top of the 3?
So that's what I was just telling them. It doesn't, no, that's okay. It doesn't matter what's on top if it's just a number, because that's always going to be positive, right? 6 is always positive. All I'm looking for is where this is negative. So all I care about is where the denominator is negative. I could have very well made this a 1 or a 20 or a negative something, negative a bit different, by just dividing both sides by 6. 0 divided by 6 is still 0. This divided by 6 would be 1 over this value, but 1 is always still positive, so it doesn't necessarily matter. That is a good question, though. Just like the 6 just disappears. Just don't worry about it.
Can you explain the subtraction part? That whole,
This
all of that.
This is a fraction. Remember, to subtract fractions, they have to be over the same denominator.
Right.
To make this over the same denominator, I multiply it by 1 in a special way to where it's the denominator over the denominator. So that gets them over the same denominator. This is any time we're subtracting fractions, we have to do this.
Okay.
What part of that doesn't make sense?
I was just looking at the negative too, like you're just looking at me. And then I was just like, okay, so you have 2x plus 3 and then you have another 2x plus 3, but we still have the 2 and it doesn't seem like we're subtracting the 2 yet. Okay.
Yeah, the 2's over here.
Okay.
I combine them over the same denominator. I've got 2 times 2x plus 3 right here. And then I just distribute it. 2 times 2x is 4x, 2 times 3 is 6.
So you distribute the 2, you don't subtract the 2 essentially.
Correct. And then I subtract it. I have to distribute before I subtract. I can't, well, I am subtracting this, but again, it had to be over the same denominator.
Okay.
So I have to multiply it by denominator over denominator to get them over the same denominator. And then I distribute this and then I subtract. I subtracted here, I got those cancel out, and negative 6. So that's where the subtraction happens.
Okay.
Any other questions? So many. Y'all are finally asking questions, which is great because the test is in 3 days. Yes.
Okay, so I wanted to ask like why the 6 has to be positive, and also when, because you put the positive over the negative, wouldn't the 2x minus 3 be negative, or is it?
That's what we looked for when 2x minus 3 is negative. That's what gave us our answer. So the reason I made this positive is just because I don't like dealing with negative numbers. So I made it positive by switching the sign there. Then 6 is always positive, which means I always want my denominator to be negative if this whole thing has to be negative because it's less than 0. Yes.
Where did the thing next to the plus equals the minus?
Where did this come from?
Yeah.
This is just true.
Oh, okay.
Like, so those were the cases. I have now a plus over something to make it negative. I want plus over minus. It's always the case that division of positives is equal to division of negatives, which is positive. It's the same thing as plus times plus is plus, minus times minus is plus. This is the same thing. Plus divided by minus is the same as plus times minus, which is minus. Minus over plus is the same as minus times plus. So this plus over here is just positive number over positive number is a positive number. Negative number over negative number is a positive number. So for example, 8 over 2 equals minus 8 over minus 2 equals 4.
Oh, okay.
Versus here, 8 over minus 2 equals minus 8 over 2 equals negative 4.
Got it.
Those are just things to keep in mind. That should more, like, it makes sense, but it's weird to write it out. Because you never see it written out. It's just something you're kind of assumed to know. We have many more hands for questions. Dan.
For the very end of it, the x over 2x over 3 is less than 0. If the sign was the other way around, would it still be positive or negative, or would it become something different?
Good question. So ignore everything from here up. We're going to redo the end of this if the outcome was different. So we're only worried about this. If I had gotten to this point and I had this, I know this is positive. Positive divided by what is positive? Positive. So I need to look for where the bottom is positive. So 2x plus 3 being positive means it's greater than 0. Negative is less than 0, positive is greater than 0. I then just solve for x. And then that would be my answer. So it would have to be, oh, that's greater sign. So now my answer is x is greater than negative 3 on 2 versus greater than positive 3 on 2 in the other way. That's what would make the outcome different. This is not necessarily like, when you're doing math, you're used to, okay, there's a formula that takes care of every single step for me. All I do is plug and chug. Here, I had to use a bit of logic and common sense to figure out my answer. The formula here is, okay, I want this to be positive. The top is positive, so the bottom has to be positive. That's the only possible choice. Then, if that's the case, where is the bottom positive? Well, it has to satisfy this condition, so I can solve for x this way. And that gives me my interval. Other questions? I know more people probably have questions. Yes.
Never mind.
No, you can ask a question.
No.
There's
not
no
related to this.
there's no bad questions, just bad answers, and hopefully I'm giving y'all decent answers. I would rather y'all ask questions now. Actually, I would rather y'all ask questions like 2 weeks ago. Now is a good time though, because again, your test is in 3 days, or 4, I guess. So we got some questions that need answered. Y'all gotta ask them.
Whole house confused.
Whole house confused. Yes.
Did you ever map this?
Yes. So when we go to talk about graphing, which will be in a little while, graphing. Oh, it'll be next. it'll be the next unit. We will talk about graphing. When we graph this, I will know how to very easily graph, more or less easily, graph a function like this. You'll learn more about graphing functions like this in calculus as well. But I'll know how to graph a function like this, and then I look, okay, where does that function go above the line y equals 2? And that would be my answer. Which is kind of what I did with the cubic equation that I drew over here. I drew it and I found where it was positive, or above the y-axis, or x-axis I mean, and went from there. Other questions?
Is it break time yet?
Yeah, it can be break time.
Thank you.
We'll make it break time for now. If you have more questions, obviously you can ask them, and we will re-adjourn in a minute.